Hey, everybody, and welcome back. Today we are looking at Chapter 2, Section 1.2, and we're going to be diving a little bit more into the Earth and what it's made of. The three big parts that we're going to look at today, we're going to talk about Earth's layers because the Earth, like an onion, has layers. And if any of you guys know which movie compares something to an onion, tell me the answer and I'll give you a piece of candy because, like, one of my favorite movies. So the earth is like an onion, like something else is like an onion. See if any of y'all can get that reference. Like I said, if you do get that reference, let me know. I'll give you a piece of candy. Um, anyway, so we're going to talk about the Earth's layers, and then we're going to talk about tectonic plates, which are important because they make a lot of the Earth's landforms. And then finally, we're going to touch a little bit on continental drift, which is just interesting, a little good fact to know. And then even though we joke a lot of the time about like digging through the center of the earth, we actually don't have the technology to dig all the way down to the center of the earth. And even if we did, we couldn't actually get all the way through. And the reason why, we will learn in a couple slides. So there are 5 layers that you would pass through before getting to the core, if you could dig through the center of the earth. Now, one of the layers, a lot of the time, is combined into, or 2 of the layers rather, are combined into a single layer, but we'll kind of talk through that. The first layer is the Earth's crust. Now, this is what we see. This contains the land masses in the ocean floor and is considered to be 30 miles thick. So the second layer is the mantle, and this is actually the layer that some people will break up into 2 different parts, the upper and the lower mantle. So this is made up of molten rocks called magma. And some of you guys might be connecting that with volcanoes, which is totally accurate. So whenever you have a volcano and you have like that magma that turns into lava, that is coming from the mantle of the earth. These layers together are 1,800 or 1,800 miles thick. And again, there are 2 parts that, and that's the upper and the lower mantle. All right, my cat Louie wants to say hi to everybody. Say hi, Louie. He's here to tell you guys about the outer core. The outer core is 1,400 miles thick, and it is made up of mostly liquid molten iron and nickel. So finally, if you traveled through all of those layers, you would reach the inner core of the Earth, which is 700 miles thick. This reaches temperatures of 12,000 degrees Fahrenheit, which, fun fact, is actually hotter than the surface of the sun. And the inner core of the Earth is made up of iron, which actually is hard because of the intense pressure that is placed upon it from all of the other layers. So the Earth's crust is not one like singular piece of pizza crust or something like that. It's actually made up of tectonic plates. These are sections of the Earth's crust that float on the Earth's mantle. So the shifting of tectonic plates causes, kind of as I had referenced earlier, a few different types of landforms and things. We'll learn how some of the Earth's landforms are caused by 2 tectonic plates pushing up against each other, which can cause things like mountains and volcanoes and things like that. Tectonic plates are also constantly shifting, and they may move up to 4 inches a year. So because the Earth's 7 continents each rest on tectonic plates, the shifting of those tectonic plates can cause the continents to move over time. Y'all might have heard about something called Pangea. This is what the continents originally looked like millions of years ago, before the tectonic plates started to move and started to push those continents apart. This means that if the world ends up being around for millions more years, a few million years, the Earth may look a little bit different than it does today. It is super important to note, though, that up to 4 inches a year is not a lot. So it's not like we're going to wake up tomorrow and the continents are going to all look different. We're talking slow moving over millions of years. The other important thing to note about the movement of tectonic plates is that this is what causes earthquakes to happen. There are actually 4 different ways that tectonic plates can move, and them hitting each other, moving against each other can cause, kind of as I said earlier, mountains, but they can also cause earthquakes. All right, so kind of like the last section, this is more of a good to know section, but I do want you guys to remember a couple of things. Remember, Earth is made up of layers, and that top layer is the Earth's crust, which has tectonic plates moving on it, which causes things like earthquakes and mountains and volcanoes and stuff like that. And then also, just kind of as a good reference, is that continental drift has been occurring for millions of years, and that the continents can continue to shift a little tiny bit every year due to the movement of those tectonic plates. All right, guys, go ahead and check in Canvas and see what your next job is, and I'll talk to y'all later. Bye.